interesting thing is that it took many years to revitalize the academy. As you have entered, there is a little column writing Academia, which is the first name. It was the boundary of the Academy of Plato. Plato established his academy to bring together the knowledge of his time, 4th century BC, and to have it expand the Lyceum, which Lyceum was dedicated to Lyceus Apollo. There are some frescoes in the main hall there. You can visit and enjoy the harmony. So harmony is a Greek word, and it covers all sciences and arts. It covers music, it covers architecture, it covers dance, poetry, everything. Harmony, to be in what we know as harmony, which is something that you like to see, to hear, or to participate, you need some principles which are based on mathematics, and they were established in the 12th century AD by Fibonacci. You know very well the Fibonacci sequences. So most of the buildings, including this one, but the big event and the innovation started with the Parthenon, which is the Acropolis of Athens. I'm sure you know it, and maybe you have visited it, where the ratios are asymmetric of any length to height or to width. The ratios are 1 over square root of 2, 2 over square root of 3, or 3 over square root of 2. So they are asymmetric numbers, but they produce an appearance that makes it attractive. Similarly, in music, we have the same Fibonacci applications. The ratios of harmonics, fifths, or the octaves, they are also, the ratio of the frequencies are asymmetric. And I'm so pleased to see old, you're not old, but I mean, known faces from the recent past, because unfortunately, most of your professors have passed away. I don't know how I survived, but I'm still here. I remember, for instance, talking for the first time at the Executive Council of Experts in WMO on the need to create the scientific advisory bodies like the ozone SAF, which was one of the first to be established. And then other activities that WMO got involved. And I'm so pleased to see people from there, and also researchers in the next generation, which is after me, and also to the little ones of the most recent era. There is, as I said, harmony everywhere, anything we like. If we like paintings or poetry or literature, So this may seem Greek to you, but it's what Plutarch wrote in his famous book, Parallel Lives. He describes parallel lives between famous people of his time before him. And in one of them, of these books, is the Julius Caesar. And he describes the eruption of a volcano without knowing that this took place on the day that Julius Caesar was assassinated. And the description is amazing. This was 44 BC. And he describes how there were no products, no everything, there was no light. The light was shaded by the aerosols, and the description, it's a very poetic in an ancient Greek language. Another well-known writer and poet, actually it was Lord Byron, who wrote a poem called Darkness. This darkness was used to describe something that you live as a dream. You think it's a dream, but it is not a dream. You live something, a disaster, for instance. So the starting of that amazing dream, a living dream, was used by Martin Luther King as a saying about a few months before he was assassinated also. You see, assassination and poesy are linked because assassination is a very heavy thing to see and listen. So he started with, "I had a dream." Of course, you remember that in his famous speech in Washington. So he describes the situation. There was no summer. It was the year 1816. We know that this year is known as the year without a summer. The reason was the eruption of Tambora in 1815. In fact, 1815 was the year of Tambora's eruption, but it was also the year of Waterloo, when it started raining continuously for months before the battle took place, which prevented Napoleon from using his artillery. And maybe this is one of the explanations why he lost the battle, not only at the time when Wellington invaded, but it was lost in the very first place when his artillery could not help him, because he was actually a man of artillery. In 1816, the Byrons, Lord Byron and the couple Shelley, they went to Geneva. They were going there quite often for summer vacation. Not far away from WMO, by the way. And they couldn't get sunshine. It was the first time that the summer disappeared, and they were locked in the hotel, both of them, I mean all three of them, and decided to write their impressions. Lord Byron wrote Darkness, but he wrote Frankenstein. So the idea of all these phenomena that they were looking at them started in this in that summer. Here are 1,000 years of all kinds of forcing, including aerosols, with which colleagues tried to explain the Little Ice Age. And the Little Ice Age could not have been explained solely by the solar irradiance forcing and other chances of forcing mechanisms, but actually you needed aerosol. And the volcanic forcing, it was a period of dense period of occurrence, of high frequency of occurrence of large volcanic eruptions. For those of you who have forgotten what is Little Ice Age, I can show you Thames frozen, also the frozen lakes in the Netherlands. This is Thames again. And this is a series of from 1750 to the year 2000, where you can see how many large volcanic eruptions have took place. And these are from real data in the period when we have data from 1750. So the idea came, why not to see if great masters could, were looking, by looking at sunsets. We need sunset or sunrise to have a long path of solar radiation through the atmosphere. And you can see here how they, Caspar David Friedrich has painted these two paintings, one about 2 years after Tambora and 3 years after. It takes about 2 to 3 years to clean the atmosphere from optical phenomena that follow large volcanic eruptions. This is actually other two cases, 1818, which is actually 3 years after Tambora, and a sunset without volcanic eruption. Here are some calculations that we found by using a method to measure the effect of aerosols in the atmosphere and in the colors, the prevailing colors, by looking at red to green ratios. We found out in a series of papers that you could get ratios of red to green which are proportional, and you could estimate the atmospheric optical depth in the visible light, like the ones you see here. They are some by Turner, and this is also by Turner, the famous sunset, which is preserved at the Tate Gallery. The Tate had also an event to show the results of our paper, and this is Turner sunset. If you translate the red to green ratios into atmospheric optical depth, then you get that picture, which actually is what was the cause for the colors you see, and how the great master has recognized his brain the different colors to be mixed and produce the painting. Using that method, we found out that in 1809 there was an unknown volcanic eruption, that now it has been established after the paper we published, showing that we could use paintings to add to our basket of data that are missing. We had no data for the Little Ice Age, no data before 1700 or so. So here is a correlation between the AOD from paintings and the DVI. DVI is the dust veil index. As you know, the dust veil index was introduced by Lamb, the famous climatology from Norwich, from East Anglia. And the DVI is estimated from all kinds of sources, including written sources. So here you can see that there is a quite high correlation between the paintings method and the method by Lamb, the DVI. Now, here it's in the northern hemisphere, you can see the volcanic eruptions, the AOD measured by them, and the temperature at in the mean temperature in various regions. And you can see that this is a superposed epoch analysis, which shows an anti-correlation between the AOD, of course, and temperature. Following Lucky eruption, Jürg Lutherbacher and his colleagues have estimated the changes in temperature in Europe that followed that. And you can see that there were a number, almost down to 2 degrees centigrade cooling following in the years following the Lucky eruption. We have been working with my colleagues on comparing our method using and studying data from 800 paintings. But some people thought that how you're selecting paintings from a period. If these, how you know the date in the first place when the painting was painted, exact date, how you know other details. We have been discussing to establish another set of available AODs. These are, of course, in the 500 nanometer region. And we decided to make an experiment. Experiment with a great master, how you can do that. So we had at the Academy of Athens a late colleague, a famous colorist, Tetsis. Tetsis was known also in the Tate, he was known in the National Gallery and in other galleries in Europe. So I asked him to paint sunsets for me In the first place, he told me, Chris, I cannot be your experimental little animal. I said, you're not. But you have that brain that produces colors, and it would be good to verify our theory. And I have explained to him, he wouldn't follow the whole story, but he's the man. He passed away 8 years ago, an amazing person, a lover of music and art, and the man who followed my very kind request to come with us and go to an island. We have selected the island of Hydra, it's not far away from Piraeus, to paint sunsets. And we defined the date to do the experiment when we were expecting a Sahara dust event to pass over. We didn't tell him anything about Sahara dust event. And when he started looking at the sun, this is the very first day when he started painting, he told me, the sun is not so clear and it is yellowish. It is not the sun that you have described to me. I said, you wait and see, and we will see what will be the outcome from your brush, actually from your brain. These were two sides of the event, the beginning when the Saharan dust passed, and then after it cleared for a while. And you can see from an expensive camera the pictures that are below. These paintings have been sent to the National Gallery in London to be digitized in the same way like they are doing with all other paintings, Turner and the other great masters. So this was the meteorological situation for that experiment. And you can see the Sahara dust. Actually, you see Greece. As I said, you can imagine where is Hydra. And you can see that it was not a heavy event, but it was good enough to produce a nice little sun curtain, which resulted in the following measurements. We had been studying separately with MFR and microtopes and other instruments, the evolution in time of the event, the profile of the dust, and here actually is what we have measured after the paintings have been digitized. And one can see Hydra 19 and Hydra 20. You can see that the increase of the paintings of Tetsis have followed the increase of the optical depth there. And then the decrease that followed is characteristic. You have a sharp and strong reduction in the day after. These are the isoplates of the optical depths, and here is the overall estimate from all paintings we studied, 800 paintings between 1500 and 2000, and you can see that there is a nice correspondence with the dust veil index that has been used. These are all kinds of publications, hundreds of them in global even in Chinese and in other journals. Now, the method has been repeated by others in California because of the humidity that is being casting sunsets there, and because of local phenomena outside of the California coast. And the results were the same. And last year, I got a note that a quite famous German photographer, he wanted to make pictures, etc. Unfortunately, I have not followed at all this part of my work. It was Stelios who has selected me to speak about it now, 13 years after, maybe 10 years after its last publication. But thank you, Stelios. You reminded me of that nice piece of work. And since I know that we that study nature, we love harmony. These are all about beauty. In fact, several of the reviewers, their comment was that they started that beautiful paper. He meant not the idea, he meant actually because we have shown the paintings as beautiful, as beauty. I think that these are just some thoughts. It remains to be seen if they will stand by against time, because time is the most crucial component in the survival of an idea. But I think that the colors in our environment, they speak by themselves. It is not accidental that there are regions and areas where living species, like the diatoms in the sea, they can produce such a nice glow in the summertime. And if you can see that glow when the moon is high in Africa, you will understand why Massenet has written Thais, and other great composers have composed hymns to the moon. Unfortunately, the light coming from the moon, except occasionally as a blue moon, has not been appreciated, not in music, but also in measurements. We have forgotten in measurements the twilight. We have forgotten the dawn, and the spectral measurements that we used to make at the National Observatory in Athens, which started actually in 1890, the time and end of twilight. And these old-fashioned measurements, they can, if you look at them, they can provide beautiful means for an optics introduction to a university course. Thank you so much, and welcome to Greece.
Okay. We thank very much Professor Zerefos for always contributing and opening new directions and new scientific fields, actually. We can take a few questions. Actually, Professor, we have people here that work on lunar photometric measurements.
Great.
So they use the moon for their work.
Yes.
Professor, greetings also from Dimitris Valis. Can you hear me now? From Thessaloniki.
Yes.
He sends his greetings. I heard about this surprising or unexpected, undocumented mega eruption you mentioned, and immediately the Hunga Tonga underwater eruption came to mind. And I'm thinking, if at the time, of course, there's no satellites, there's no eyes in the sky, if it was such a case that we had a huge underwater eruption somewhere so remote,
Yes,
that filled the
very
sky?
nice question. Thank you. Hunga Tonga was actually the event of the millennium. It was not a simple volcanic eruption. We say Tambora was one of the largest, or if not the largest in the past 1,000 years. But no, Hunga Tonga, what it did, it has taken a small island submerged under the sea in a great depth. Its energy passed the depth of the sea, and with an amazing speed, it penetrated the stratosphere. So the bad thing with that eruption is that we did not get the sulfuric emissions and all the aerosols, the fresh and old volcanic aerosols, but they were all transported in the stratosphere. So in the stratosphere, of course, it has helped to increase the humidity there. And some colleagues like Susan Solomon and Irina Petro-Pavlovsky and Sophie Godin and myself, we think that the low values of ozone, actually the continuation of the ozone hole in Antarctica, it is still maintained by all that humidity that started 4 years ago. It took long for it to spread from one hemisphere to the other. That's one hypothesis. The other is that this Hunga Tonga has many other applications, but we can see them only spectrally. So your suggestion, I think it's very much justified, that we definitely need to not to stay with the water vapor part of the spectrum, but also to look at other parts of the spectrum in the stratosphere. Maybe the limb measurements, or I don't know, maybe we need a spectral radiometer. Yes. Is there any other? Okay, thanks again.
Can I ask a question?
Sorry, I think we have a question online. Do we have a question from the attendees?
Yes. Hello.
Yes,
Can you hear me?
Yes, please.
Yeah, this is Franco Marenco. Hello, Professor C.Zerefos.
Hi, Franco.
Thank you very much for this very, very fascinating and interesting talk. You were mentioning volcanic events, but also Saharan events. And of course, there is a very different effect on the global scale and on the temperature if the event is in the troposphere or in the stratosphere. Are you able, by analyzing the time sequence or the correlation between different locations, to distinguish between these two?
We have not done, that's a good idea. We have the data, anybody who's interested, we can compare. But the Sahara dust events, are a lower atmosphere. I mean, they happen up to 2 kilometers or 3 kilometers, not extra height. But the volcanic events, of course, they stay in the stratosphere for some time and they produce this beautiful coloration of sunset. But I agree that we should compare. The reason that we used that was the only way to get aerosols overhead a master in painting, And Sahara dust is something that happens almost every year. In fact, the local name of Sahara dust is called by the Arabs Hamsin, it's a wind associated with that, and it is called Hamsin. Hamsin in the Arab language means 50, and it means that for 50 days you have danger that you could be exposed if you live in Sahara. I was born in Cairo, and my family comes from Alexandria from a long time, so I'm used with these events, and it would be quite impressive, because when you see the sunset through such a simoon type event, the sun becomes reddish, and it is becoming more red and more red until it can disappear because of the thickness of the sand and the aerosol that comes with it. In fact, the first Hamsin simoon type event has been painted by David Roberts in 1870 in Arabia, outside of Mount Sinai. So these are events that are quite impressive, and I'm sure that it will be very helpful to get some more information, although the scattering ensemble is completely different from the fresh or old volcanic aerosol.
Photometry. Join the action, join the newsletter. Follow us on social media for news and announcement.